Welcome, my dear students, to the discussion about mathematics. Previously, we are looking at the issues pertaining to the sets. This time around, we have a new topic that's about the mapping and functions. Right, I need you to stay put and be steady so that the discussion too in this topic has to be worthy, be considered. Right, request is given to you all. That's wherever possible you feel like you can comment, you are free to comment, and we would prefer if you do so that maybe we can polish up our videos for your own goodness. Share the videos again to others who you feel have no access to these videos. Show them the link that is down here, and advise them also to go through all the videos starting right away from the beginning when we had the first topic about the quadratic expressions and equations. Right, let us now take ourselves into business. Right, as the area mentioned, we are to look at a new topic that's about the mapping and functions. Right now, before we do anything else, can we try to learn about the objectives that will take us through up to the ending, so that whatever we expect in the topic has to be reached successfully. Right, mapping and functions, the objectives of which are as follows. That's by the end of the topic, you students of mine should be in the position to define mappings and then define the functions as such. Right, what are mappings? What is a function? And therefore I should be also in the position to present the mappings and functions in different forms. Right, how do you present the mappings and how do you present the functions? That's now after we have defined what mappings and functions are. Then the very last part would be the issue that's related to the calculations, where we'll be always in the position of calculating the members which are regarded in the set of the range and members which are found in the set of the domain of a particular function, which means we'll have two sets of our discussion in this topic, set of the domain and set of the range. Those are the central field of the discussion in this topic. Right, so now we are wasting much of the time. Allow me to first of all consider issue about the mappings, where we need to define it and look at all issues that surrounds it. Right, mapping, mappings. Right, when we talk of mappings in this category of discussion, we are looking at the relationship. So you can simply define a mapping just see as a relationship that links. A mapping is a relationship that links talk of the members of two sets. Mappings, if we are to define the mapping, we are simply talking of what? A relation. So the whole discussion here about this topic is about the relation. A relation that links members of two sets. For example, here with me, I've got some items of this bag of mine. You know that one is a hammer, masking tape, a cup, a notebook, this is a pen to marker. Got this one, wood, that's fine, match box, the matchsticks inside here, and we also have a tablespoon, finally, I've got nails. Right. So by the definition that I have the board here, where we're talking about the relationship that links members of two sets. You'll be able to bear with me here. In front of me, there are several materials here. You find that if I can start categorizing these materials here, you'll be able to see that, say, there are some materials which are related to each other. You can describe the relationship that is there. Like, say, for example, I can have a hammer, and here I've got nails. You can be able to describe that really the relationship between nails and hammer. If you're a carpenter, you know what I mean. So just like a hammer and nails are in two categories of sets. So hammer is linked to the nail. If you're a carpenter, you can at least be able to produce chairs when you have a hammer and nails. I also have masking tape. You can be able to deduce what is it that is going to link with the masking tape. On the board here, on the chalkboard, we have got a chart. So you can be able to see that I'm using this masking tape to paste the chart on the board. So it means masking tape is related to the what? To the chart. Then once it is a hammer and nails are related. Then I also have this category here. That's a tablespoon and a cup. The two are related. In that a tablespoon is used to stir whatever liquid substance is in there. Suppose this is tea and you have got sugar inside here. You like to take tea, you always do the stirring. So you can consider the item spoon and the cup are related as members. Right? I can also talk of the matchstick. Matchstick in the matchbox here and the wood are related. If you like to light fire, you always consider the match sticks and also the wood. Right. So if I can keep on grouping, I can group these items in front here. More importantly, not forgetting the notebook and the pen. These two are also related. If you like to take down whatever we're discussing, you always need a pen. You won't need wood. You won't need a cup, but you're going to select a pen and a notebook. Right. So now, by the definition, they are going to categorize my materials here into two sets. I'll have the notebook here, a cup. So if I have a notebook here, it means you have a pen. I have the cup here, it means I've got what? A tablespoon. If I've got a nail here, it means this hammer should go toward the side. If here I have got matchbox, it means this one goes toward the side. If here I have got a seal tape, definitely if I pluck this chart out, it has to fall in this category. Right, and also it applies to the pencil marker. If it falls here, it means the chart here. So what you can have here, in fact, that here is the first set that has got a cup, notebook, talk of hammer, matchstick, pencil marker, seal tape, one set, and the other set has got wood, talk of a pen, talk of a tablespoon, nail, and what have you. The chart falls here. So that's it. So it'd be like when you say a relation is the one that we have just described here. You know how any one of the two are linked to each as the way we use them in our everyday life. Right. So I think now you have got at least a direction of what we are going to do in the mapping. Like here we're talking of just a relation that exists between them. So you should be in the position to define that relation. Right. Further examples on the relation about the mapping. We need to discuss this one in detail before we get into the functional side. We have several relations that now we can be able to produce in our everyday life. Apart from this example that we have had here, we may also have a particular relation that can be described by easy a mother of The moment we talk of is a mother of, it means what we expect here is just like two categories of sets. One could be the set, maybe set A. This one is a set of what? That one is a set of mothers. Just that relationship will bring two sets. And set B should be the set of what? Children. Right. So if maybe, for example, we are there to introduce the members in set A of mothers represented as talk of K, N, and Y. Let K represent particular mother, N representing a certain mother, and Y representing another mother. For the children, it means we expect to have a situation like this. We're describing up now the set of children by this: A, X, Y, B, F. So here are just like parents, here are children. And if you find out that, say, a mother defined by K has got a child who is X and Y. And on top of the mother N has a child who is A, and the mother Y has got a children in this case B and F. It means if we are there to introduce issue about the mapping, we have to show the relationship that exists between set A and set B. So how you could bring that one forward, it will be like you can write down the set A and set B in this manner, like you say, here I have got set A and here set B. So for A, what do we have? We have K, N, Y. Here is the set of children. Who are they? A, X, Y, B, F. So from what I described earlier, where I gave you a link whereby I was describing which children on this side belong to mother K and which children belong to N, which children belong to mother Y. You need the position to trace it out by using the lines whereby mother K has to take care of children X and the child Y. Right. While mother N is going to take care child A, and the lastly mother Y is going to take care of children A and B. So this presentation here tells us a relationship that exists between set A and set B. So we'll be saying like K is mapped, talk about mapping, to X and K and Y, meaning that K is a mother of X and Y. And also A is linked into B. Then Y linked to B and F. So you say N is mapped onto A, Y is mapped onto B and what? And F. So that's it about the mapping. We talk of a relation that exists here between two sets. So we talk of the set of the mother and set of what? Children. Right. That example in the same relation, so which means in this case, the moment I like this category here, on this side and this category, I should also be in the position to describe the relationship that exists between the set A and set B. So we'll be there to say set A defines is a mother of, just the way we like. It should be in between here. So the arrows, the lines which are in between here, that they are being defined by is a mother of. Right. Another example in the same mapping for you to understand better, because it's you first of all need to know more about the mappings before we take our step into the function as such. We can have another relation here that is described as is a multiple of. Is a multiple of another relation. A relationship defined as is a multiple of. Right. Just by that, you two can be able to produce two sets, which can be defined by is a multiple of. So it means here we are referring to, for example, two sets of natural numbers. Let's say one set is a multiple of the other. Meaning to say it's a set of numbers that can be divided by another category of numbers, which should be found in the other set. Like say, for example, if I arrive and say we have got two sets here, set, maybe talk of set n, defined by the following numbers, 2, 3, and 5. And the other here, set p, defined by numbers like 4, 6, 8, 10, 15, and 30. Look at that. Is a multiple of. You first of all have to define multiple. A multiple is a number that can be divided by another number. So like here, if you can look at two sets here, you find that all the numbers which we have in set P can be at one moment in time be divided by numbers in set N. So you can say set P are numbers which are multiples of numbers in N. So that if I'm there to present the relation that exists between N and P, it means my presentation by say is a multiple of will be like this. Look here. It will be like this. I'll have my first set as P because talk of the is a multiple of, and another set which is defined by N. Right. So P will have, from what we presented earlier, sets 4, 6, 8, 10, 15, then what? 30. On the other side, we have to see these numbers being divided by another category of numbers. So check on this one. Here have a 2, here have a 3, and here we have a 5. So what it means here is just like you can be able to compare set P and set N. You can be able to identify which numbers in set N can be divided in any one of those numbers. So like a 4, you find that 4 is divided by 2. So here it means 4 is mapped onto 2. And here you also see that 6 can be divided by 2. So you write a line like 6 mapped onto 2 like that. It means 6 is related to 2. And then the 6 can also be divided by 3. So you map 6 mapped onto 3. And when you look at 8, can also be divided by 2. Then look at what? 10 can also be divided by 2. So 2 is just like a number that can divide into several numbers, set P. 15 can be divided by 3, can be divided by 5. 30 can be divided by 5, by 3, and also by what? By 2. So look at that. So the lines you see here are linking members in two sets by definition, set P and set N. So say 4 is mapped onto 2, 6 is mapped onto 2, 8 is mapped onto 2, 10 is mapped onto 5, 15 is mapped onto 3. That's the language we bring in. So here it means in the middle we're going to write is a multiple of. Right. That's in between the two sets as such. Right. So that's it about mapping. So when we talk of mapping, we are there talking about the relationship. We talk of the relationship that links the members of two sets, like set P and set N. What the relationship here? The relationship is described as is a multiple of. So is a multiple is a relationship that links the members 4, 6, 8, 10, 5, and 30 with 2, 3, 5. Right. Now, is a special way how we present the mapping. We don't just write for the sake of writing as such, but we write the mapping in a special way. So let's discuss that to say how do we present the mapping, the relationship that exists between members in a particular set. Right, so let's discuss this one out. Right, so even here, I think we have taken note of the objectives of the topic that we have studied today. So allow me to remove this chart here to create more space where we can discuss our content very peacefully. Right. So now we're going to discuss next is an issue that is related to the what we call the arrow diagrams. Right. Arrow diagrams. Right. Logically, that's what we're doing. We have defined what mapping is. We have given you 2 examples and how issues are related. An area we have discussed about the practical tips in the real life situation of the materials that have been flagged. Our diagram are just ways of presenting mappings. That's all. Mappings or point relationships. Right. So which way the relationship exists between the 2 sets has to be presented by the arrow diagrams. So here, let us discuss how we can come up with these arrow diagrams. There are 2 main ways on how we can present the arrow diagrams, but other areas of concern as far as we talk of the relationship existing between whatever diagram we can have, there's no problem with that. But what matters most is the presentation of the members in a way that they relate with each other. Right. Now here, so the first category here, I'll give you an example. Right. For example, suppose we've got 2 sets of values. One is set talk of set B, another is set A. Right. From what we had earlier, let's have set A with members, so I set B first of all, with members 5, 10, 15, 20, 25, and 30. And the members in set A are 2, 3, 4, and 5. You can describe several relationships that can exist between A and B. Maybe to catch up, let's just take the first one, the relationship that's defining A and B. Let's consider that these values in B are the multiples of A. Meaning to say the values in B can be, some values in B can be divided by any value in A. So if I'm going to present a mapping by the arrow diagram, first way, the arrow diagram looks something like this. Presentation of A and B, where the relation shape is defined as the is a multiple of. Right. So what I do here, I will draw my diagram in this manner. Look, you have your ruler, you take it like this, and another line down here, like this. Right, so on this part, I think if I can just love this part here, because we are done away with this, can be much better, so that my extension comes as far as here. And here we are stopped somewhere here. Right. So temporarily, can I just remove the word mathematics? We're reading on maths. So what we do here, we consider this one as a number line, has an arrow heading towards that way, and the arrow heading towards that way. So what I'll have here, will be numbers which are found in set B, and this arrow here will contain numbers which are found in the other set. So I have to show the link that is there between set A and set B. So how we present this one? By our diagram, I'm decided to scale this one out by having here 5 here, 10 here, then 15 for this first set, then here I've got a 20, and somewhere here we've got 25, and here 30. Presentation of the members in the what? Two sets by our diagram. But here now, it'll be like I'll have a 2 here, I'll have a 3 here, I have a 4, I have a 5. Right. So in between, I can have between this and this. I'll say this one is set B, this is set A. So we are writing is a multiple of. Look at that. So now, can I map or say link the members of A and B by this diagram? So it'd be just like you can say these numbers here can be divided by what? From A. So you'll be able to tell me that 5 can be divided by 5, so this one links with 5 like this one. So you produce an arrow like this one. So the issue about the arrow diagram has to be well explained. 5 can only be divided by 5. 10 can be divided by 2, so you come like that. And the same 10 can also be divided by 5. You go there. Then you look at 15. 15 can be divided by 5 again. And 20 divided by 5 again. Apart from 5, 15 can be divided by 30. Look at that. 25 can be divided by 5. The arrows like that. And then we talk of 30 can be divided by 5. So 5 is just like dominating in this case. The same 30 can be divided by 3. Right. I think we have exhausted everything. Right. Then 20 here can be divided by 4. Right. So look here. If you can try to compare what we have on the board here, you find the representation of set A and B defined by the relationship is a multiple of. You find that this is true about this. So this set is this line here, and this other set is this line there. So the two are ranking. Right. Lastly, let's have another way of presenting the that's a talk of the what? That's a relation existing between two sets. Apart from drawing the arrows, which are more like number line, there's another way how we can draw the arrow diagram. Right. So let's look at this as an example. Right. This example is they are giving us a relationship that exists between two sets, and these sets have got members which are represented by countries and have got particular cities. So like here, what I'll do, if I'm going to present these members, I'll have category here, category A of the cities defined by T, like this one here. And the members in T, we say they are related to members in talk of set C. When you look at T, T is a set of towns, while C is a set of countries. So around here, I'll have a diagram that looks something like this one. Another way, apart from drawing the arrows. And then here, I'll have another set of C that looks something like that. Look at that. So what do we have here? About the towns, we have Lilongwe. We have here Lilongwe. It may light the better way. Lilongwe. Let's just take it in short form like that. We have got London. We have got what? Nairobi. We have got what? Zomba. What else? Blantyre. What is it again? Mombasa. Lastly, we have got Edinburgh. That's the Edinburgh. Right. Countries which are there to be linked by these towns in the other set, we have got UK, we have got Kenya, and finally Malawi. Right, it's mapping. So if I'm there to link members of set T about towns and the set C of the countries, it's just a matter of us finding out, say, which town is found in which country. So you see that Lilongwe is found in Malawi, and the R diagram looks up like this one, and I've got an R touching Malawi. And then we talk of London. London is the town in UK, so I link it with that one. And then I've got Nairobi. Nairobi is a town in Kenya. So you see, we are mapping, they're using the R diagrams. And I've got Zomba. Zomba is a town in Malawi. We have got Blantyre. Blantyre is a town in Malawi. Then you talk of Mombasa. Mombasa is a town in Kenya. And finally, we have got Edinburgh. This is a town in UK. Right. So what do you do in between here? It was just like as we did earlier. We had two lines going this way. In between, we have to state the relationship that is there between this and this. So you'll be able to write it, say, is a town of. That's it. So the relationship that is the linking T and C is what? Is a town of. Right, so for today in this video, this is what we had. We have introduced ourselves to the mappings. We have said mappings is just simply the relationship that links members in two sets. So by the example that we have had here, I have all hope that we have understood what a mapping is all about. Right, so in the next discussion, that's the next video, we're going to discuss something about the types of what? That's mappings or types of relationships. Thank you very much for being together. And do not forget always to be updated by yourself with the link that is down here of the videos. Have to be paid now and again. Share with your friends. It's very, very important. Right, thank you.